Hey guys, so this is my VESC board. What's special about this one? Well, this one's got lights. Most of the VESC boards you'll see out there, no lights at all, and I personally wasn't going to accept that. I hated riding this board without lights, and I just feel safer riding at night. It's easier to be seen, it's easier to see, and the board just flat out looks cooler. I'm going to do what I can to simplify this process for other people who want to do the same to their board, because it was a bit of a headache to figure out how to make it work. So what's special about this? These are brighter than XR lights, noticeably brighter than XR. Maybe not GT bright, but they're bright. They are RGBW, so there is a web app where I can change different colors and animations to whatever I want. And then this board specifically, I didn't really want to get on a web app every time I'm riding, so I added a button on the inside of the handle here that allows me to toggle the lights. With a single click, I can go through and pick some different taillight presets I've built, as well as some fun headlight and taillight presets. These are maybe less useful when riding, but they sure look cool. So we'll go back to my little workspace and I'll show you how I got it configured. So for the LED strips, I chose SK6812 strips. They're addressable, run on 5-volt power, very bright. They're RGBW, so they have a dedicated white diode. Good output for a headlight. I've cut 2 strips of them, 22 pixels each. These are the 144 density versions. You'll see a couple versions when you're buying these. You can buy them by the meter. So 2 strips, 22 pixels each, and then I just put a JST connector on the end. One note, these can be a little wide for some enclosures, like a XR battery box. You'll need them to sit a little lower, so you can just trim the side of these along where this directional arrow is. Just take some scissors, trim those down a little bit. Just don't cut too close to the diodes themselves. The tricky thing with the little fucker is there's no acceptable power output to drive the LED strips. There's a 5-volt out, but it's got very low amperage, so we need to power the lights directly from the battery. But if the lights were plugged into the battery, it would drain constantly. So we need the lights to turn on and off whenever the VESC turns on and off. So we'll use the 5-volt line on the Fokker to trigger this relay. This is a solid state relay. It's from Panasonic. It accepts 5-volt signal in onto these signal pins here. Let's see if I can. So your 5-volt signal will come in here and back out here, and when that happens, it will close the relay and our battery connection will be connected here. And our batteries, they're anywhere from 60 to 84 volts. So we need to step down the voltage to 5 volts. So I've got this buck converter here. These are cheap ones, AliExpress or eBay. Goes up to 120 volts and outputs 5 volts. So the way this will work is our VESC will turn on our relay. The relay will allow power from the battery in, and it will go into the buck converter and then into our LEDs. So next up is a ESP8266 board. These are very cheap, and I have an open source LED software called WLED running on it. This is the whole brain of the operation, controls all our settings and outputs. I've assigned different pins in the software to drive the 2 LED strips and detect the status of a push button. I have a push button right here. It's an 8mm waterproof button, momentary, also found on AliExpress. So connecting all of this did turn into a little bit of a rat's nest in my board, but it does work. However, I've been doing some commission work on boards for some other folks, so I decided to make this process a little easier. So I've taken all of this and I've built a PCB that contains all of these parts in a semi plug and play way. So if we take a look at that there. XT30 in directly from the battery. We've got our input for the 5-volt from the Fokker, ports for our 2 light strips, and a port for a momentary button. You'll see in here, I've also got a fuse in it, as well as the necessary resistors to get the relay and the button to work. So for your controller box, you're going to need one that has an LED window. The floatboxx or the elmbox will work well. This is my personal remix of the flow glider box. It's got an LED window, which I will epoxy a sheet of polycarbonate on the front. There's a small hole up here for the momentary button. I've exchanged the XLR for a GX16, and I've ditched the Molex for a cable gland. This is going to free up so much real estate up here for this controller and all of the wiring. I'm not going to say it won't work with a Molex build, but it will be a very tight fit. So I'm working on a floatboxx build for a friend right now, so let's take a look at the cabling on that. So I remixed the file they have on the floatboxx website for the LED holder to accommodate the strips I'm using, and it just slots right in there. And you just need to glue on your window. Alright, so PCB is mounted with some VHB tape. Our cable harness comes out here with the discharge line right in here. I've added some little 22 gauge wire that forks directly out of the discharge line. Terminates into an XT30, which plugs into my LED controller. So battery power comes in, this end goes to the VESC, and then this comes out and goes into the LED controller. We've got the 5-volt rail on the wheel fucker right here, and that plugs directly into the VESC 5-volt port on the LED controller. So then our LEDs are mounted according to the floatboxx instructions. Headlight comes in from this little cable gland over here, and that plugs into the headlight port here. In our harness, I dedicated 3 wires to come out and be for the rear light. So that plugs in right here, just harness directly into here. And then last is this momentary button, the final port. I drilled an 8mm hole and put this small 8mm momentary button. I think next time I'll probably do it over here next to the cable gland. It's just a little too crowded over here. There's a little more space on this side. But yeah, so I drilled a hole, button goes in. The one thing with this is I realized that I'm using JST XH connectors on here, and it's a little large to fit through that hole. So I crimped this, and I didn't put the connector on until I put the button in, and then I plugged the crimps into the little connector, just space reasons. And so with all that, that would be everything I have to do on this side. So I would just plug my discharge line in. So this is the end going to the fucker. I don't have my motor cables connected or anything yet. And that would be ready to go. So let's now go over to the battery box. There's a torque box here on my harness. I've made my discharge circuit. And then down here, I've got my 3 wires that go to the LED strip. I've just used the JST connector, but you could solder this directly if you wanted. Whatever harness you use, you must have 3 dedicated wires in the harness for the rear light. So those come over here, and I've just glued this LED strip in here. You can maybe mount this better than me, but hot glue is fine. Once the BMS is pressing against this, there's no way this is gonna move. So that's just glued in. I did have to cut this strip a little shorter just to make it sit low enough. You always wanna line it up with your bumpers and just make sure the lights are aligning properly with the cutout on your bumpers. So we'll tuck that in. That would be all I have to do on this side. And I can plug my discharge in. So we'll plug that in. And so now everything should be all plugged in, ready to go. If I hit my button, VESC turns on, and so does my lights. Look at that. And if I hit my momentary button in here, let's see. Look, I can trigger my other presets. All right, so let's take a look at the WLED settings I have pre-configured here. Just for demonstration purposes, I'm running off just the USB port right now for power. So when you turn on the controller, go to your Wi-Fi settings, and you'll see one called WLED-VESC. You'll connect to that. The password is WLED-VESC. 1, 2, 3, 4. And once that connects, the control page should automatically pop up. And there it is. So if it doesn't pop up, just go to your browser, go to Safari here, and type in 4.3.2.1, and there it is. There's a lot of tutorials on this already, so I'm not going to go too deep here, but let's look at what I pre-configured. So if we go to segments, you can see there's the headlight and the taillight. And by default, you're only going to make changes to the taillight, and the headlight will remain white. But if I select both, then our changes will go to both. So let me go back here to colors, and if I want my taillight to be green, I could just move it down there, and now the taillight is green or blue, and I can select different effects and whatnot. Over on presets, we'll go to my default, which is default red tail with a white headlight. If you look through, I've notated all the ones that are just the taillight have a T, and then ones that affect the headlight and the taillight say HT. So we can hit on tail magenta or tail cyan. So the first three presets are identical to the push button actions. 1 toggles on and off, 2 cycles through taillight presets, and 3 cycles through headlight and taillight presets. If we go to the config, we can see how I have that set up. We go to time and macros, button actions, and button 0 is our push button, and these are the values I have assigned. If we go back and hit LED preferences, you can see the config for our 2 strips, notating the length of the strips and the type of strip we are using. Farther down, we can go to our defaults, and we can say apply preset at boot. 10 is my default red tail, this one, so you could change that to anything you wanted to boot as. And then under Wi-Fi setup, leave this top one blank, but you could rename this one to include a personalized name so it doesn't get confused with someone else's board, and password if you want it. And then after you change it, just hit save and connect. So any of these presets can be overwritten with something else if you like. So if you didn't want this one, you could change the color, go back to presets and hit overwrite with state, and it will save this as a new preset. If you just want to add them and not overwrite, you go down and you hit new preset, and if you add them into the numbering scheme I've done here, when you go into the cycles, this for the taillight cycle basically is saying cycle through presets 10 through 18. So you'll just increase this value to fit whatever presets you make or whatever range it is. So same thing over here on the headlight, taillight. This one goes 20 through 26. So if you added more after 26, you would just increase that number to include all the presets you've built.
I hope this video was useful for those of you who want to build this from scratch. I'll have a link in the description for my PCB if you want to buy that, as well as links to all the downloads for my 3D files and some reference material. Thanks.